With expanded aneuploidy analysis, or EAA, powered by the Myriad Women's Health proprietary algorithm, we can now screen for aneuploidies in all autosomes in the genome. Expanded aneuploidy analysis expands the utility of non-invasive prenatal screening because it allows us to screen for not only abnormalities in the fetus, but also overall pregnancy complications. This capability to screen for aneuploidies other than the ones identified in chromosome 13, 18, and 21 is clinically important because such aneuploidies may be associated with placental mosaicism, uniparietal disomy, and true fetal aneuploidy. We performed a retrospective analysis of 49,000 samples and characterized the prevalence and the degree of mosaicism of chromosomal aneuploidies. To estimate the prevalence of each chromosome, we examined high-confidence positives characterized with Z-scores, which reflected the significance of enrichment or depletion in WGS read density. We show that about 1 in 200 screened with EAA were aneuploided for a chromosome other than the 3 typically screened. Collectively, the frequency of the additional set of aneuploidies amounts to 59% of the overall prevalence of the aneuploidies conventionally screened. In addition to prevalence, we also characterize the relative degree of mosaicism of these two groups and show that the frequency of mosaicism differ between the two. To measure the degree of mosaicism for each sample, we computed the ratio of the two independent measurements of fetal fraction, the one from trisomic signals and the other inferred from the autosomes. By examining this ratio, we can tell whether the given aneuploidy is mosaic or partial. Here, we compare the degree of mosaicism profile of chromosome 21 and chromosome 7. About 1.02% of samples positive for chromosome 21 were estimated to be mosaic. In contrast, for chromosome 7, 75.4% of positive samples were estimated to be mosaic. Incorporating the prevalence, degree of mosaicism, and fetal fraction, we established the analytical aggregate sensitivity of 99.62% and the overall specificity of 99.95% for the additional aneuploidies. This characterization has important implications for interpretation of NIPS results. We show that mosaicism is common, not an edge case, when performing expanded aneuploidy analysis, and this must be taken into account when reporting positives. Therefore, characterization of the prevalence and the degree of mosaicism for these less common aneuploidies on our platform can provide additional value in clinical practice.